So let's take a look at another trajectory problem. Here we're going to look at the specifics of motion as this object falls. And so if we drop an object from a height of 120 meters, we'd like to know what distance it falls during the last second of its flight. So let's think a little bit about how we might set up this problem. I think in terms of trying to set up where we are in terms of height, we're going to choose the positive direction to be upward. So this will be the plus y direction. And my object is going to start at a height of 120 meters, and it's going to end at a height h equals 0. So that will be the motion that we're looking at. Now the real question is, how do we figure out where it is at the last second of its flight? And so one of the ways that we can do this is to figure out how long it takes to fall from 120 meters all the way down to height equals 0. Since the equation that describes its motion tells me where it is at any given time, if I know how long it takes to fall this full 120 meters, I can wind the time back 1 second. Wherever it is, 1 second before it hits the ground must tell us how far it has to fall during that last second of the flight. And so that if we can find out the total time, we can wind back a second and figure out where it is 1 second before it hits. That must imply that it falls that distance during that final second. So that's the plan. So we can look and see, we can write down our equations using a distance equation to describe where it is. So the final position is equal to y initial plus v initial times time. And since we define the positive direction to be up, we're going to write minus 1/2 gt squared here. So this is our equation that's going to describe the motion. The original velocity, since it's dropped from rest, is going to be 0. My original position is going to be 120 meters. And so my final position when I hit the ground is going to be y equals 0. So we can rewrite this equation then as 0 is equal to 120 minus 1/2 gt squared. So if I can solve this equation for time, it will tell me how long it takes to fall from a height of 120 meters to 0 under the acceleration due to gravity. And so clearly we can just move this onto the other side. So I can write 1/2 gt squared is equal to 120. And so that tells me, if I solve for time, that t is equal to 4.95 seconds. So that's the total amount of time it takes for the object to fall from 120 meters all the way down to the ground. So 1 second earlier, at a time of 3.95 seconds, we can find out where it was here, and then will tell us how long it takes or how far it falls in the final second. So y at 3.95 seconds is going to be equal to 120. We have no initial speed still, so I can just write this as minus 1/2 g times the total time that it falls to that point, which is 3.95 seconds, squared. And so if I calculate this out, I get that the y at a time of 3.95 seconds is equal to 43.5 meters. So that tells me that during the final second of its fall, it starts at a height of 43.5 meters and reaches the ground at 4.95 seconds. So it falls 43.5 meters during the last second of its flight.